Let's talk about significant digits. We've been working on a calculation, and here is the result our calculator shows us. So how many significant digits does this have? The real answer to this question is, we simply don't know. You need to know how your numbers were originally measured and how the uncertainties move through the calculations. And those are techniques that we're saving for university. So at the high school level, we keep our rules very simple. If we have a number like this, and we are showing our work in the calculation steps, and we want to write it down, the important thing is that we do not write all the numbers that our calculator shows us. Most of these digits are simply not significant. They are not useful to write down. So our simple rule is this. During calculations, we will only write 4 significant digits. So on this screen here, the digit 2, 4, 4, and 4, those are our 4 significant digits. Everything else we'll just cut off, so we just truncate it. And we end up writing a number that looks like this. And now the rest of these digits are cut off. And here is our number written with 4 significant digits. This is an example of where scientific notation can be helpful because this number is difficult to read and interpret. Now you can carefully count the digits there and you would say, oh, this is 24 million. But this is a case where writing the number in scientific notation will make it easier to read and understand. So here we have 7 positions to move our decimal. So we'll write 2.4 times 10 to the power of 7. So here we have a result written in scientific notation. Let's take a look at the significant digits in a small number. We ignore the leading zeros of a small number and begin counting the significant digits with the digit 1. As is our practice for writing numbers during our calculation steps, we want to write this with 4 significant digits. So we'll have the 1, 0, 5, and 9. The rest of the digits we simply truncate, we cut them off. If you're ever wondering about which digits are significant, a good way of thinking about it is like this. Imagine we wrote this number in scientific notation. So in this case, we would move the decimal point over 2 spots, and we would have a number 1.059 times 10 to the power of negative 2. And here we see the 4 significant digits in this number. So it's only the leading zeros that we leave out when we have a number smaller than 1. The final part of our practice with significant digits is when we write a number as part of our final statement. This is the stage at which we will round our numbers. So our rule is, in our final statements, we will record the number with 3 significant digits and round off the remaining. So in this case, our significant digits will be the 1, 0, and 5, and we're rounding off the rest. So the rest begins with a 9, which means we will round up. And so we will write this number as 0.0106, showing our 3 significant digits. Now our rule of thumb for scientific notation is we want to use this to make our numbers more clear or easy to read. So we will never use scientific notation to write numbers like this, because this is already easy to read. We won't use it to write numbers like this. This is already easy to read. But as soon as we have numbers that are very large or very small, it can become easier to read them using scientific notation. Or, if for some reason we want to very clearly show which numbers are the significant digits, we can also write it in scientific notation. So it's a tool that we use to make our mathematical work more clear or easy to read. We don't use it in all cases.